Hello students, welcome to aimsindia online classes. This is a chemist session. Here we are discussing about atomic structure topic. In this session, we are going to see the practice sheet related to this chapter. In that there are two kinds of practice sheets. First, let us say about practice sheet 1, which includes completely single correct answer type questions. So first let us see here conceptual understanding questions. Mostly they will be theoretical based upon the concepts which we have learned in the previous sessions. And that these questions will be. See the first one. The first atomic theory was proposed by. Who was the scientist who proposed the first atomic theory? Actually, the concept of atom and the theories were given by many scientists. Of course, because of some drawbacks and limitations, they were kept failed. We are following some now, and some are failed. But out of this, the first theory of atom was given by John Dalton. So, I say John Dalton's theory was the first atomic theory, which has given some idea and proposals about the structure of the atom. Okay, John Dalton. Next one, the idea of smallest unit of matter was proposed by. So here a little to avoid the little confusion they have given in the bracket about anu and parmanu. Some hints are given. Of course, actually, the first concept of atom was given by we told John Dalton. But in the earlier days itself, in the ancient time itself, in our India, our saint Maharshi Kannad has given the idea of Anu and Paramanu. So to avoid the confusion, in the bracket they have given Anu and Paramanu. So the concept of this Padartha, Anu and Paramanu was proposed by Maharshi Kannad. If they ask in the exam, in the question, the first atomic theory was proposed by, it will be John Dalton answer. If it is asked clearly here, the concept of Anu and Paramanu was proposed by, that will be Maharshi Kannad. Okay, next one. Cathode rays were discovered by. Actually, this cathode ray experiment or discharge tube experiment was done by William Crookes. So at the first time when he was doing this discharge tube experiment, he observed some particles emission inside the discharge tube. When a gas is taken inside the discharge tube at a very low pressure, and when the high voltage current is applied, he observed that certain particles are being emitted inside the discharge tube. But he did not give much clarity about those particles, what kind of particles are those. So the same experiment was repeated by one more scientist called J.J. Thomson. So in his experiment, he observed and given clarity about those particles. They are cathode rays. So the credit of discovery is given to J.J. Thomson, even though the discharge tube experiment was earlier done by William Crookes, but the discovery credit is given to J. Thomson, as he was a scientist who done experiment on this cathode rays, and he has given the complete properties of those, description about the properties of these cathode rays, like what is the charge of those particles, how they are being traveled, what the mass of these particles, how these are being deviated in the presence of electric and magnetic fields. So these all properties were explained by J. Thomson. So the discovery credit of these cathode rays is given to J. Thomson. Here one more point we have to remember, that is the discharge tube experiment was first time done by William Crookes, but the discovery of electrons was done of electrons or cathode rays. We know these electrons were earlier called as cathode rays by J. Thomson because these are being produced and being transferred from cathode side to anode side in the discharge tube. So they were called cathode rays. Nowadays we are calling them as electrons. The name electron was given by G.J. Stoney. So the discovery of cathode rays was done by J.J. Thomson. Next one, the entire positive charge is present in a central region of an atom called. The entire positive charge or protons of an atom are present in the central part of the atom. What is central part of atom is called? Yes, it is called nucleus. nucleus. The total positive charge, even the total mass of the atom, is concentrated in the small central part of the atom. That central part is called as the nucleus. So the size of the nucleus is very small when compared to the size of the atom. Total mass is concentrated in that small part only. It is a nucleus. Next one, according to Rutherford. See here some statements are given about the nucleus and the particles revolving around the nucleus. Which statement is correct according to Rutherford? You observe once. See the first one. The neutrons revolve around the nucleus. Is it correct? No. Neutrons are being in the center part of the atom called nucleus. They won't be revolving. See the second one. The nucleus revolves around the electrons. Is it true? No. Nucleus will be at the center part of the atom. It won't be revolving. Now the next one. Electrons are revolving around the nucleus. Yes, it is correct. Electrons are the subatomic particles which are revolving around the nucleus. What is the next one given? Protons are revolving around the nucleus. This is also incorrect because protons and neutrons are present at the center of the in the center of the atom called nucleus. Around this nucleus, electrons are revolving in the concentric imaginary circular paths, which are called as the orbits or shells. So now electrons are the particles which are revolving around the nucleus. That is correct. This is a statement given by Rutherford. The total positive and total mass of the atom is concentrated in the nucleus of the atom. Around this nucleus, electrons are revolving in the circular paths. So this is a correct statement about Rutherford's concept. The total number of protons and neutrons present in the nucleus of an atom is called. What is it called? The total number of protons and neutrons present in the nucleus are called nucleons. So the sum of these two numbers, sum of the total number of protons plus total number of neutrons, the sum of these two is called nucleon number also. It is also called mass number. Mass number or nucleon number. Okay. So here both are given. Mass number is given, nucleons number is given. So it will be correct answer both B and C. Next one, the number of neutrons present in the tritium. What is this tritium here? We know hydrogen has 3 isotopes. Again, here what is meant by isotopes here? The atoms, the same atomic number but different mass numbers are called as isotopes. So here hydrogen has 3 isotopes, namely protium, deuterium and tritium. So tritium is a radioactive isotope of hydrogen and it has 1 electron, 1 proton and 2 neutrons. Actually protium has no neutrons, only 1 proton, 1 electron are there in the protium. And deuterium is one more isotope of hydrogen which has 1 neutron along with 1 electron and 1 proton. And the third one is a tritium. It has 2 neutrons and 1 electron, 1 proton. So it has 2 neutrons. They're asking about the number of neutrons present in the tritium. So there are 2 neutrons. Which of the following pairs are not isotopes? So what is the meaning of isotopes we have heard? We have learnt isotopes are the atoms which are having same atomic number but different mass numbers. They are called isotopes. Just now I have seen here. Tritium is a radioactive isotope of hydrogen because hydrogen has 3 isotopes. Protium, deuterium and tritium. These 3 are called isotopes. So what is common in them? They all belong to the same element. These atoms belong to same element. That means they have same atomic number but they differ in mass number. So the atoms which are having same atomic number but different mass numbers are called as isotopes. See here they have given some symbols of the elements. So this also we have learned how what is being represented by these symbols. The number which is written at the subscript position beside the symbol of an element represents atomic number, and the number written in the superscript beside the symbol of the element represents mass number of the element. Now see, the atoms with the same atomic number with different mass numbers will come under isotopes. See here, carbon, carbon, both are having same atomic number. Here, mass number 12 is given for the first one, for the second one it is given 14. So these two are having same atomic number but different mass numbers. So we can call these as isotopes now, isn't it? Yes. Next one, if you see in the second one, now both are having the same atomic number, nitrogens. Atomic number is being 7. If you observe mass numbers, it is having 14, it is having 15. So they are having same atomic number and different mass numbers. So can we call these as no isotopes? Yes, we can. So this is also isotopic pair. Now see the third one. Atomic number is same for these two, 8 and 8. But if you observe mass numbers, it has 16, it is having 18. So they differed in the mass number but having same atomic number. So this pair also comes under isotopic pair. But if you see the last one, the first species is having the atomic number 8, whereas second one is having atomic number 9. So they differ in atomic number. If the atoms having same atomic number, different mass numbers, then they are called isotopes. But if they have different atomic numbers, then they are not said to be isotopes. So this is not an isotopic pair. What they're asking the question, which of the following pairs are not isotopes? So these two will not come under isotopes or isotopic pair. Okay. Next one. Atoms having same number of neutrons are called. What are they called if they have same number of neutrons? The atoms the same number of neutrons but at different atomic numbers and mass numbers are called as isotones. You can remember easily here isotopes. For them it will be here P, means they will be having proton number same. Proton number same, nothing but atomic number same. Atoms with the same atomic number are called isotopes. And here for isotones also you can remember easily here. It is N. Okay, actually here it should not be. So this N represents number of neutrons. So if the number of neutrons is being same, then those are called isotones. Definition for the isotones we have as the atoms with the same number of neutrons but different mass numbers and atomic numbers are called as isotones. Okay, it is isotones have same number of neutrons now. Next question, which of the following is true regarding electromagnetic radiations? So here some statements are given regarding electromagnetic radiations. Let us see those one by one. They do not require any medium for their propagation, isn't it? Yes, electromagnetic radiations do not need any medium for their propagations. That means they can travel through even matter or even through vacuum also. Yes, it is true regarding EMR or electromagnetic radiation. Next one, they consist of both electric and magnetic fields. Yes, actually these electromagnetic radiations are produced or emitted by the electrically charged particles which are moving with high velocity, like electrons. So, as these are produced by electrically charged particles, these electromagnetic radiations are also containing both electric and magnetic fields. So, this is also true. Next one, all electromagnetic radiations travel with velocity of light. Yes, this is also true. All the electromagnetic radiations travel with the velocity of light. That is 3 into 10 to the power of 8 meters per second or 3 into 10 to the power of 10 centimeters per second. This is the velocity of all kinds of electromagnetic radiations. So this is also true. Now what will be correct answer? Yes, it is here, all of these. Next one. The number of waves passing through a point per second is called. What is it? It is a definition for frequency. The number of waves passing through a point per second is called frequency, nu. Next one. The wavelength for a given type of electromagnetic radiation, is it directly proportional to frequency? Is it inversely proportional to frequency? What is the relation between wavelength and frequency? We have studied that wavelength and frequency both are inversely proportional one to another. If a wavelength is greater, its frequency will be less. If its wavelength is smaller or shorter, then frequency will be greater for that electromagnetic radiation. So we can say wavelength and frequency both are inversely proportional one to another. That's why we write this relation. Nu is directly proportional to 1 by lambda, or nu is equal to C by lambda. So from this we can say these two are inversely proportional to one another. So where is it? The second option. Wavelength is inversely proportional to frequency. Next. As frequency increases, energy of the electromagnetic radiation. So what is the relation between these two again? Frequency and energy. We have an equation according to quantum theory of radiation is directly proportional to frequency, or E is equal to h nu. So from this we can say frequency is directly proportional to energy. If frequency is greater, energy of the radiation also will be greater. That's what they're asking here. If frequency is increasing, then energy of the electromagnetic radiation also increases, because both are directly proportional one to another. Increases. Next one. Quantum theory of radiation was proposed by. Who proposed this quantum theory of radiation? Max Planck. What did he say in that? Energy emitted by the particles is not being continuous. It is being discontinuous in the form of small packets called quanta or photon. The energy of this each photon is directly proportional to frequency of that electromagnetic radiation. So this theory was proposed by Max Planck. This theory is called quantum theory of radiation, which was proposed by Max Planck. Next one. The combining capacity of an element is called. What is it called? Valency. What does it mean here, combining capacity? Elements which are having 8 electrons in their valence shell are being more stable. They are being unreactive. But the elements with less than 8 electrons in their valence shell are being reactive or unstable. So these elements will try to acquire 8 electrons in their outermost shell. In this trying, some elements they lose electrons, some they gain electrons, and some other they share electrons. This number of electrons gained or lost or shared by an element to become stable is called its combining capacity, which is also called as valency. Okay, the combining capacity of an element is called its valency. Next, single correct answer type questions. First one, the smallest particle of an element that displays the properties of that element. Yes, the smallest particle of every element which can display the properties of an element is called its atom. Atom is the smallest particle of every element which can show, which can display the properties of an element. It is atom. Next, the E by M ratio of anode rays depends on. What are these anode rays? Actually, Goldstein discovered these anode rays with the same kind of experiment which was performed by J. Thomson in the discovery of cathode rays. But he used the screen behind this cathode. So he observed then some particles are being emitted from anode side and passing towards the cathode side. So he called these rays as anode rays, positive rays, because they're moving towards the negative electrode. So he called these positive rays as anode rays. But here, between the cathode rays and anode rays, the major difference is cathode rays are independent of any gas taken in the discharge tube. But the anode rays are being varied from gas to gas. Okay, these anode rays are being changed from when you change the gas taken in the discharge tube. So the E by M ratio of cathode rays is independent of the gas taken in the discharge tube, whereas the E by M ratio, what does it mean here? E by M ratio, specific charge, charge to mass ratio. This charge to mass ratio is being changed for anode rays when the gas taken in the discharge tube changed. So it depends upon the nature of the gas taken in the discharge tube, or nature of the residual gas in the discharge tube. So if you take hydrogen gas, we get one kind of EBM ratio for anode rays. If we take helium gas in the place of in the hydrogen, then we get one more EBM ratio. In this way, as we are changing the gas, EBM ratio also being changed. Now we can say EBM ratio of anode rays depends upon the residual gas taken in the discharge tube. Next one, the heaviest particle among the following. So in the atom, there are different kinds of subatomic particles. Out of these all, protons and neutrons are having somewhat heavier mass. It is nearly equal to 1 AMU. But out of these two, neutron is having a little higher mass. If you say inaccurately, proton mass is 1.007 AMU, whereas for the neutron it is equal to 1.008 AMU. So it is slightly heavier than that of proton. So the heaviest particle among all the subatomic particles is a neutron. But in calculation, generally we take the mass of proton and neutron will be equal as 1 AMU we consider it. But to say accurately, neutron's mass is somewhat greater. So the heaviest particle in the atom is neutron. Next one. In the nucleus of calcium. So what does it contain? Nucleus, protons and neutrons. So how many protons are there? How many neutrons are there? So from those all we can identify based upon the numbers mentioned here. This subscript number gives its atomic number. Nothing but number of protons. So number of protons is now 20. We can eliminate this option because they have mentioned 40 protons. Now number of neutrons we have to get. This mass number represents sum of the protons plus neutrons. Now already we know protons number is 20. Then what is the number of neutrons we get? 20. So the nucleus of calcium contains 20 protons and 20 neutrons. Okay, this is the correct option. Next, neutron is a fundamental particle which carries. Yes, what does it carry, neutron? What is the charge of neutron? It is a chargeless particle. It has no charge. So we can eliminate these two now. What is the mass of neutron? It has 1 unit mass. So neutron has 1 unit mass and no charge. 1 unit is nothing but 1 AMU nearly. Isn't it? Around 1 unit mass is there for neutron and it has no charge. So what will be the correct answer now? It is that. Next one. An atom has 26 neutrons and its atomic weight is 56. The number of neutrons in the nucleus of the atom will be. So what are given here? In the neutral state, an atom has 26 electrons. We know for a neutral atom, number of electrons is equal to number of protons. And we know number of protons number is taken as atomic number. Okay, number of protons is 26 now. And its mass number is given as 56. So if you know mass number and proton number, we can calculate number of neutrons. So number of electrons is equal to number of protons for the neutral atom. So it is equal to 26. And the mass number is given as 56. From these two we have formula to calculate number of neutrons as number of neutrons is equal to mass number minus atomic number. Because we get mass number by by taking the sum of protons and neutrons. Isn't it? So if we subtract this atomic number from the mass number, we get number of neutrons. So 56 minus 26 gives mass number of neutrons as 30. Okay. Number of neutrons we can calculate by subtracting atomic number from mass number. Next, mass number of an element is always equal to. So to which it is equal mass number? We know mass number is nothing but nucleon number. Nucleons means sum of protons and neutrons. So the number of protons and neutrons together is considered as mass number. Next, Na plus ion is isoelectronic with. Isoelectronic. What does it mean here? Isoelectronic? The species with the same number of electrons. So now they're asking Na plus is isoelectronic with. So it means which of the following is having same number of electrons as this Na plus. What is the number of electrons in Na plus? First of all, we know sodium atomic number as 11. So there will be 11 electrons in sodium atom. Now they mentioned here Na plus. It means it lost one electron. So in original, in the neutral atom of sodium, there will be 11 electrons, but it lost one electron. So finally there will be 10 electrons in this Na plus ion. So Na plus has now 10 electrons. Now you observe once which of the following given options has 10 electrons it. So it will be the correct answer. What about the lithium plus? Atomic number of lithium is 3. In the neutral state, lithium will be having 3 electrons. But here they mentioned Li plus means it lost one electron. So it will be having only 2 electrons. What about Mg plus 2? Magnesium has 12 electrons. Neutral magnesium will be having 12 electrons. But they have shown here Mg plus 2 means it lost 2 electrons. So in this there will be 10 electrons. So this will be the correct answer. Okay, it is isoelectronic with Na plus. What about Ca plus 2? Calcium will be having 20 electrons. It lost 2 electrons, so it will be having 18 electrons. So these are higher elements. They'll be having more than 8, more than 10. Now, correct answer is only magnesium. Next, select the pair of isobars from the following species. So they're asking to find out isobaric pair. What is meant by isobars? Isobars means the atoms with the same mass number but different atomic numbers. They should have same mass number. Observe once which two atoms are having same mass number here. See, A has mass number 37 and if you observe for C also it is 37. So the pair of these two, A and C, will come under isobars because both of them having same mass number 37. So A and C. Okay, next one. Which of the following electromagnetic radiation has highest frequency? So electromagnetic spectrum we have in the earlier classes. The radiations with a greater wavelength will be having less energy or less frequency. They are radio waves. That is why they won't cause any harm to us. But some electromagnetic radiations like cosmic rays and X-rays, they have very less wavelength, very short wavelength. So they will be having very high energy as well as high frequency, which are much dangerous to us. We should not be exposed to those such kind of radiations. So out of these all, cosmic rays are having highest frequency as well as highest energy. Okay, cosmic rays. Next, the value of Max Planck's constant in C.G.S units. So the value of Planck's constant they're asking. The value of Planck's constant is 6.625 into 10 to the power of minus 27 erg second, or 6.625 into 10 to the power of minus 34 joule second. So these two are the values of Planck's constant. But here they asked in C.G.S units. So in C.G.S units, Planck's constant value will be 6.625 into 10 to the power of minus 27 erg second. Where is it given? Yes, here. It is correct. Next, as the distance from the nucleus increases, energy of the electron. So it means as the electron is being far away from the nucleus in the higher orbits, its energy will be greater. Okay, as electron is being much far from the nucleus, its energy will be much greater. As the distance from the nucleus increases, energy of the electrons in the orbits increases. Where is it? Here, energy of the electron increases. In the same, one more question is there. Don't be confused here. As the orbit number increases, energy difference between the adjacent orbits. Of course, we came to know in the previous question, as the distance from the nucleus increases, energy of the electrons in the orbits increases. That's correct. But although the energy of the orbits increasing, the difference between the adjacent orbits decreases. See here like this. The energy difference between the E1 and E2 is greater than the energy difference between the E2 and E3. And it is greater than the energy difference between the E3 and E4. So in this way, as the distance from the nucleus increases, the difference between the energies of adjacent orbits decreases. Okay, got the point? It decreases. Next one, the wavelength of a blue light is 4800 angstroms. The frequency of the light is. So they have given wavelength and asking to calculate frequency. What relation we have between these two? We know frequency is directly proportional to 1 by lambda. That is, frequency is inversely proportional to wavelength. To remove the proportionality, we have taken a constant here c. So the equation becomes now nu is equal to c by lambda, where lambda is the wavelength which they have given already, and c represents velocity of light, that is 3 into 10 to the power of 8 meters per second. So if we substitute these two values, we get the frequency. See, the wavelength they have given in terms of angstroms. So if we convert these angstroms into meters, we get this extra, because 1 angstrom is equal to 10 to the power of minus 10 meters. So now here lambda or wavelength will be in meters, and velocity of light is taken in meters per second. So what do we get answer here? Finally, 6.625 into 10 to the power of 14 second inverse. This is the frequency of that radiation or that blue light. Where is it? In the first option. Next one, calculate the energy associated with the photon of light whose frequency is 3 into 10 to the power of 15 second inverse. So they have given here frequency, asking to calculate energy. What relation we have between these two? We know energy of the radiation E is equal to h nu, where h is constant, Planck's constant, nu is frequency. So we know the constant value and frequency already it is given. So if we substitute these two, we get the energy. H value is 6.625 10 to the power of minus 34 joule second, and the frequency is 3 into 10 to the power of 15. Now we get final answer in joules. 19.87 10 to the power of minus 19 joules. But all he given with one digit in the decimals. So 1 point we have to convert. So if we convert this into 1.987 into 10 to the power of minus 18 joules, it is in the B option. Okay. Next one. The electronic configuration 2, 8, 6 represents. So for which element it is electron configuration? To know that, if you see the sum of electrons from all the orbits, it gives its atomic number, because it is neutral atom. So if you observe, totally there are 16 electrons in the given electronic configuration. So atom with 16 electrons or atomic number 16 is sulfur. So it is electronic configuration of element sulfur. Okay, this is about conceptual understanding questions and single correct answer type questions. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website www.aimstoday.in for latest updates and recorded videos. Thank you.